Hello everyone, welcome to our presentation n-Gage, Predicting in-Class Emotional, Behavior, and Cognitive Engagement in the Wild. I'm n-Gage, a PhD candidate from MIT University. Imagine when you are giving a math class to students. Do you want to know? Do they pay attention in your class? Do they pretend to listen but actually not? Do they enjoy your class? Do they feel discouraged during the group discussions? Are they actively thinking what they are learning in class? Student engagement refers to the degree of attention, interest, curiosity, and involvement in the learning environment. Generally, student engagement are divided into three categories: emotional, cognitive, and behavior. As reported, as many as 40 to 60% of high school students are disengaged, which may lead to the low academic performance, low disaffection, and high dropout rates. Therefore, in this research, we mainly aim to tackle the following questions. First, can we measure the multiple dimensions of high school students' engagement, including emotional, behavior, and cognitive engagement, with sensing data in the wild? Second, can we derive the activity, physiological, and environmental factors contributing to the different dimensions of student engagement? If yes, which sensors are the most useful in differentiating each dimension of the engagement? In the research, we collect data from daily survey, indoor weather station, wearables with multiple sensors. The data collection lasted for 4 weeks last year in a private high school in Melbourne, and in total we have 23 Year 10 students participants and 6 teacher participants. The engagement prediction pipeline is as follows. We use sensor data as input, engagement score as output. We apply data preprocessing techniques and sensor data, and then we use machine learning models to predict the multiple dimensions of engagement score. This table shows the extracted features from multiple sensors. For example, EDA sensor can measure the sweat level of skin. It is a very common measure of autonomic nervous system, and which have been increasingly explored in the affective computing area, such as the detection of emotion, depression, and engagement. In the research, we have also proposed some new features, marked with star, to compute physiological synchrony between the student and the average value of the other students. It has proved to be very effective in our experiment results. Because student learning engagement can be influenced by many factors, such as thermal comfort, which will be affected by the environmental changes, such as CO2, indoor temperature, and humidity. Therefore, we calculate the statistical features for the environmental sensors as an overall estimate of indoor environment. For the experiment result, we first evaluate the overall prediction result with all sensors available. The following table displays the MAE and RMSE scores of engagement regression in different dimensions. We can see that our system can achieve higher prediction performance for all dimensions than the baselines, which shows the potential for predicting multidimensional engagement for students. The following two figures shows the engagement distribution and prediction error over 23 student participants. You can see that each participant have a very different error distribution. For instance, participants 8 and 16 have the highest value of prediction error. And also in the first figure, we can observe that they have a much lower engagement level than the others. The potential solution may be to build the group-wise or participant-wise regression model in the future. In this table, we identified the most influential features on different dimensions of engagement. We also shows how the different sensor combinations can affect the prediction performance. In the table, S1 means all the wearable sensors, and S2 means all the environmental sensors. In addition, we explored the prediction results based on different subjects such as math, English, and language classes. This figure shows the engagement scores on different subjects. It is very interesting to find that students have the highest cognitive score on the math subject than all the other subjects. We also showed how the engagement score changes with different class time and more comfort. For example, students usually have the lowest engagement score after lunch. Also, when they prefer a cooler environment, that is to say, when they feel warm or hot, they usually have the lowest engagement score, especially the lowest cognitive engagement. Our research provides opportunities for the future design of feedback systems in classrooms and have potential to benefit both teachers and students. Thank you for listening. If you have any questions, feel free to ask me.